Hello and welcome to this short tutorial on how to use the Slidesheet Editor in KellyDown. For this example, we're going to assume that a gyro was run from surface down to where the MWD run will be tied on. In the Database Explorer, you can see the gyro survey and then the MWD run number 1 tied onto it. So to open the slide sheet, right-click on the survey and select Drilling Slide Sheet. The first thing you'll be asked is to enter the bit distance. That's the distance from the bit to the MWD's survey sensor. So for this example, we're going to use 28.5 feet. Click on the OK button. And now you see the top line, this is the tie-on line for the slide sheet. And the survey depth is set at 983 feet, which is the bottom of the gyro survey. And the bit depth is 1011.5 feet, which is the survey depth plus the sensor to bit distance, which is shown at the top. If you click on the Tie on Survey Depth button on the toolbar, you'll see all the data pertaining to the survey tie-on. So the bit measure depth, the survey measure depth, and then the tie-on information that's carried over from the parent survey, which was the gyro survey. So click on the OK button. A few things to note on the Slidesheet Editor is you can change where the frozen columns are. Right now the frozen columns are just beyond the survey azimuth, and if I move the scroll bar at the bottom of the screen, you can see that the columns to the right of that survey azimuth will move backwards and forwards, and the first so many columns are frozen. And to change which column you want to have frozen, you click on the column, right-click and select Freeze Columns. So I'm clicking on the survey depth, selecting Freeze Columns, and now all the columns to the left of the survey depth are frozen and all the columns to the right are allowed to change as you move the scroll bar. As with all worksheets in KellyDown, you can change which columns are displayed. So right-click on any of the columns and then select Edit Columns. There are a set of default columns associated with the Slidesheet Editor, and those are listed on the right here. You can go back to the set of default columns by clicking on the bottom at the bottom right. The default set consists of whether the record has a survey associated with it, the activity, the start and end times, the course length, bit depth, survey date, etc., and the general survey information. Further down you'll see the turn rate, build rate, slide scene, motor output, and such like. You can add to the columns by going over to the left hand side and either double clicking or selecting a few and then clicking on the add button. So we'll add moving average output and slide percent. So select those two by holding the control key down and clicking on each one you want, and then click on the add button. And they're added to the bottom of the list. You can bring them up to where you want them by clicking on the ones you want to raise, and then click on the move up button. If you hold the control key down, this will move them up 10 records, and then just clicking on that button will move them up 1 record at a time. So we're going to put the moving average output, motor output, underneath the motor output, and the slide percent just under the slide information. And then click OK to add those columns to the list. So let's start adding data as if we were drilling ahead. But before we start, let's assume that we've arrived on the rig 24 hours earlier and we were on standby until they started drilling the well. Go down to add a new record, select standby. The course length will be 0. By default, the start time and end time will be selected as the time you created this new record. So let's assume that we arrived at the rig on the previous day, which was Sunday the 7th of August, and we arrived on the rig at 10 o'clock in the morning. So we're just about to take our first record, and this current end time for standby is 10:20 today. So we've been on the rig for 24.35 hours before we start drilling, and we haven't drilled yet. Our current bit depth is still 1011.5. And because we're on standby, we haven't taken a survey, so there's nothing else to enter on to this line. There are a number of activities you can choose from this drop-down list. For instance, if we need to run into hole down to the bottom of the gyro survey, We can select tripping in, and once again KellyDown will enter the current time. And because this record isn't a drilling record, the survey checkbox won't be checked, and the course length remains at 0 and the bit depth is still 1011.5. So let's now enter a drilling record. So enter a course length for a piece of drill pipe, let's say 28.55 feet, and as we tab off, KellyDown will calculate the bit depth, the survey depth, and assign the current time to this record. Let's assume for this record we're continuing to drill down towards our kickoff point. So we'll enter a small inclination, 0.6 degrees, and an azimuth of 250 degrees. So scroll across to the right. We weren't sliding during this drilling section, but we were rotating for the full length of time that we were drilling. So we can enter an equal sign under the rotate time, and that will assign a complete 14 minutes to rotation. So let's click on the next record and enter a course length of 27.76. Tab across to the survey inclination, and let's now assume that we've been on our kickoff. So we'll enter an inclination of 4.87 degrees along a direction of 206 degrees. Scroll along to the slide length, and let's assume we were sliding for 20 feet of this 27-foot section, and our tool face orient was 230 degrees. And we were sliding for 10 minutes of this section, and KellyDown calculates that the rotate time was the remaining 4 minutes of that 14 minutes. As we enter the information on this line, KellyDown fills in the information on the previous line that it can now calculate because we've entered a bit depth for this current section. Let's just add a few records until we've reached about 15 degrees in the hole. You see now that our inclination is almost 15 degrees, and as we enter each row of data, KellyDown calculates the dogleg, build rates, turn rates, the motor output, and the rate of penetration for the slide and rotate values. The motor output value is the amount of build and turn that the motor is achieving. So for instance, our inclination of that last section changed from 12.6 to 14.8 in a course length of 27.87 feet. And so that equates to an overall motor output of 16.15 degrees. At the top of the screen, you see the slider head value. This is an estimate of how much slide there is in the hole between the MWD sensor and the bit. So from this value, we can calculate what the likely inclination is at the bit. For example, we know that the slider head value here is about 28.5 degrees, and our motor output is 16.15 degrees. Therefore, if we divide 28.5 by 100 and then multiply that by 16.15 degrees, that's an estimate of how much turn or build there is between the MWD sensor and the bit. We can add that value, which is 4.6 degrees, to the current inclination of 14.8 degrees. So KellyDown is estimating that our inclination at the bit is 19.4 degrees. This helps us to keep track of our inclination and make sure it's following the well plan, and also warns us about when we need to stop applying slide to the drill pipe when we reach the desired inclination. Remember, the slider head is only an estimate. Each time we enter a record, KellyDown doesn't know what the next course length is going to be. So the slider head can only be a maximum of the center to bit distance. So the slider head value is an estimate of the residual slide between the MWD sensor and the bit. Once we've finished drilling this section of hole, the final activity is to trip out of hole. So go to the next row, click on the activity drop-down list and select tripping out. KellyDown will select the current time for the end time and set the course length to 0. So now we need to close this slide sheet and create a new one that's tied onto this one. So go to the Tools menu and select Create New Slide Sheet. A warning message is displayed, so answer yes. So KellyDown creates a new slide sheet that's tied onto the previous slide sheet. KellyDown has assumed that the sensor to bit distance is the same as it was in the previous run. But for this example, we're going to enter a sensor to bit distance of 36.25 feet. The first row on the worksheet contains the tie-on information from the previous run. So the distance between the bit and the survey depth for this run is still 28.5, and you can check that by looking at the tie-on survey depth. The bit depth is 1236.74 and the survey depth is 1208.24. The difference is 28.5 feet. So the first thing we need to do is trip the string back down to the bottom of the previous hole. So select tripping in from the list of activities. KellyDown retrieves the last time from the previous run and the current time, and then calculates the number of hours between the end of the last run and tripping down to the bottom hole. So the tripping in time is assumed to be 1.2 hours. Let's continue to enter a drill record with a course length of 27.05, an inclination of 17.1 and a direction of 225.5 degrees. And now you can see that the distance between the bit depth and the survey depth is 36.25. So let's continue to enter some more records to build some more inclination into this hole. So you see here that now we've built to 41 degrees of inclination along an azimuth of 230 degrees. Before we finish this tutorial, let's just have a quick look at how the Slidesheet interfaces with the projector head modules. So if you look at the motor output, it is 13.475. That's the calculated output from the motor based on the change in inclination and azimuth and the amount of slide. And the slider head distance is 31 feet. So KellyDown is telling us that there's 31 feet of slide ahead of our survey instrument towards the bit. So if we open the correction run module, and you can see that the sensor to bit distance is 36.25. The course length for the slide is 31 feet, and the dogleg rate is taken from that motor output, which is 13.475. And then the final 5.25 feet is assumed to be rotating, so there's 0 degree dogleg. And this is used by the correction run and all the other forward projection modules to project from the survey depth down to the bit before correcting to the proposal in this case. Thank you for watching this tutorial.